We talk about what is a function and what is a function notation. So two important things for a function. First is the domain and second is the rule. So they can have the same rule but different domain, which will be two different functions. Okay, and then we learn how to write a function notation, which is name such that domain mapping to R, comma, like the name of the function, bracket x, and equals to what kind of rule. Just finish writing the rule there. So today we are going to talk about one thing called implied domain or maximum domain. So what is an implied domain? Not all, like for example a linear. Let's say before we just write x plus 1, y equals x plus 1. What domain do you assume in that case? All real numbers. That's what we in year 9, year 10 trying to sketch a linear. What we assume is like x can be any number. When it's not telling you, okay, when it's not specified, okay, domain is -1 to 10. When it's not specified, we assume that it's just anything, okay, anything. So so what is maximum domain? Is when the domain is not specified, we take as much as we can. Okay, we take all the numbers with a meaning. Okay, we take all the numbers with a meaning. That's called the maximum domain. So give your example what value cannot give the function meaning. If we say y equals to square root x, the maximum domain, like the interval I can have is x belongs to 0 to infinity. I can't take any negative number. I can take 0. Square root 0 is a 0. But I can't take square root -1 or -0.5. Like square root a negative number, that's no meaning for it. Okay, in real number, like in math method, there's no meaning to take a square root of a negative number. Therefore, my maximum domain, even though I didn't say what is like the domain, but we will say that's 0 to infinity. Okay, that's from 0 to infinity because that's the maximum value will give this function meaning. Okay, so that's the maximum domain. So there are 3 things we need to be aware of. So far we only learned 2. Okay, so far we only learned 2. We haven't learned the log function yet. So only 2 things. Like say now we have 2 things we need to be aware of. The first thing is the denominator. Okay, the denominator. If you have x in denominator, okay, we need to make sure denominator will not be 0. Okay, if there is x in the denominator, which means your denominator is changing, like it can vary from value to value. So we need to make sure the denominator is not 0, which is this case. Okay, if you can see case number 2, that is, well, this is like, I make it really in details, like what kind of situation you can have. But like, overall, there are only 3 things. So the first is when you have x involved in the denominator, we need to make sure the denominator not equals to 0. So the whole thing and the denominator will not equals to 0. Okay, you'll see examples in a minute. The second one is, well, square root, like 4th root, 6th root, or any even root. Okay, any even number of root. So, well, square root, you know what square root, like 4 square root 4 is a 2. Okay, so 2 times 2 is 4. So the root to the power 4, like the 4th root, that will be something times something times something times something equals to the number you put under the 4th root. So it never becomes 0. Okay, it never can be 0. So same thing times 4 times together, it must be a positive number, even though originally it's negative. So I must have positive number always. So for this kind of root, if we have x in it, we need the inside to be greater or equals to 0. Like the inside, well, I don't know what's inside. Inside can be a single x, it can be 2x plus 2, can be 3x minus 1. So just the thing under the square root needs to be greater or equals to 0.
Doesn't that apply to odd roots as well?
No, all root can be negative. Cube root -8, that's -2. Because 3 things times together, you can have negative. Yeah, -2 times -2 times -2, that gives you -8. Only apply to even roots. So like we haven't learned log. Like the third one is talking about the log. So the first three is the basic three, and then 4, 5, 6, they are a combination of things. Like you don't really need to remember 4, 5, 6. You just need to remember the first three and then apply to it. That's enough. Sometimes you may not have like a single like square root or the denominator. It can be a combination between the square root and the denominator. So you have a square root and the denominator. That's possible as well. So it needs to satisfy both situations. But anyway, let's have a look. Okay, for the first one, well, I don't know this equation, even though I don't know how to sketch the equation. I have no idea on what type of equation is that. But what you can observe, like what we have, like if we think about the maximum domain, what you can see first, like what's the restrictions? The denominator can't be 0. So we will have square root 1 minus 5x cannot be 0. What else? What can't be an...
X can't be larger.
You can give me an inequality. Give me an inequality.
1 minus 5x has to be...
Yep. Well, if you don't think about the denominator thing, it can be greater or equals to 0. Okay. If you don't think that's a denominator thing, like 1 minus 5x can be 0. If you just think about that's a square root. But plus is a denominator as well. So we need to like overall, like this and that, we can give for 1 minus 5x is greater than 0. Okay, can't equals to 0. So this is because the denominator. This is because of the square root. Okay, and the overall, you need to satisfy both. So if you want to satisfy both, the square root don't want that to be 0. So therefore, you have 1 minus 5x just greater than 0. Do not make that equals to 0. So 1 is larger than that. 1 on 5 is larger than x. So we will write in the interval notation, x belongs to negative infinity to 1 on 5, exclusive. Okay, exclusive. Okay, for the next three, I want you to write all the inequality or not equal, like any equations which can help you to find the maximum domain. Okay, and if possible, just solve for it. For example, this one, the first one, I need 1 minus 5x to be greater than 0. That's what I need to solve and then find what my x should be. Can you just do the same thing for 2, 3, and 4 as well? Is that an and or? And if it's an and, you need to satisfy both. You want to see intersections between those two sets. Yeah, you want to satisfy both. So what part of x can satisfy both of them? Well, just do by yourself first and then check your answer with me. So as we can see for the second one, this one, okay, someone like just a little bit confused about like when we can use the equal, when we can't use the equal for square root. If you just consider about the square root by itself, it can always be 0. There's square root 0, nothing wrong with square root 0. But why this one we don't have the equals to 0? Because it's the denominator. I don't want to make the denominator to be 0. That's why I make 1 minus 5x only greater than 0. If 1 minus 5x is 0, then your denominator will be 0 as well. That's why we can't make it equals to 0. So because of both of that, we only have, that gives us 1 minus 5x is greater than 0. But for the second one, there's no denominator, there's no such thing. So it's only a square root and a false root. So what I need is 2x minus 5 greater or equals to 0 and 10 minus 3x greater or equals to 0. So it can take equal sign for both linear equations. So if I can solve for this, that is x greater or equals to 5 over 2. And I need x less than or equals to 10 over 3. First of all, you need to know which number is larger. Okay, this number is 3.333 and that number is 2.5. Okay, so it's two different, like 2.5 is smaller. So I will show that on the number line. 2 over 5 and 10 over 3. It's very important for you to know how to use number lines to find the intersections. I need an intersection, which means I need the intersection between two sets. My x needs to satisfy the first equation and also the second equation. Therefore, I will sketch that on the number line. X is greater or equals to 5 over 2 is this green one. Less than or equals to 10 over 3 is this red one. So you can see the part with two colors must be 5 over 2 and 10 over 3. A lot of you just directly write 5 over 2 and 10 over 3. I'm not sure if you really know why it's like that, or you just think, oh, two numbers, I just put it together. So that's why we have this number line. Is the intersection, is the overlap between the two colors. If you have more inequality, you find the overlap. That's the way you do it. You use another color on top to sketch for it, and you see which part got 3 colors, and that's the intersection. So I will say x belongs to, because I can take 5 over 2 and 10 over 3, I will write square bracket to that. Okay, I will write square bracket to that. Any questions? Okay, that's the second one. Well, for the third one, is the quadratic cannot equals to 0 because it's the denominator. Okay, denominator can't be 0. So also plus there's a square root. So I can only make the thing inside to be greater than 0, not equals to 0. How we solve quadratic inequality? Okay, don't forget that. We just learned that. X plus 1 times x plus 6 to be greater than 0. I need the graph to help us to solve that. I don't need the y-axis even. I just need to write -6 and -1 at the right place and then sketch the graph. Oh, it's a positive graph. I need the part to be greater than 0, which is the y value greater than 0. It's from those two red parts. So the corresponding x will be this part of the x and this part of the x. There's two ways of writing it. First one is negative infinity to -6 exclusive -6. I don't want the 0 point. Okay, -6 give you the 0 point. So it's open circle at those two x-intercepts. You don't want 0. negative 6 will give you 0. If you sub negative 6 into that function, that will be 0. I don't want 0. Okay, I'm not going to take the x-intercept. Union, I'm not going to take 1, but I want 1 onwards. So it's 1 to infinity. This is the way, like, really easy to write. Okay, just write from here to here and stop. Union from here to here. There's another, yes? Negative 1, yeah, it's negative 1. Yes, thank you. There's another way we can do it, which is a little bit hard. I'm not really recommending, but like someone really like this method to write like intervals. So I can say x belongs to R except negative 6 and negative 1, but inclusive negative 6 and negative 1. So which part I don't want is the middle part. Okay, the middle from negative 6 to negative 1. Do I want to exclude negative 6? Yes, I want to exclude negative 6 and negative 1. That's why we have square bracket there for negative 6 and negative 1. I don't want it, so I will exclude it with a square bracket. If I want those 2 points, I will use round bracket, not to exclude it. Okay? So 2 ways to write this. Okay, 2 ways to write this. This is like a set. Include like an interval, like some, like a whole group of values, infinite many values from a point to a point. Okay, from a point to a point. Let's have a look at the last one. 4x plus 1 greater or equals to 0 and 2x minus 1 not equals to 0. Okay, now square root is on the numerator. I don't care whether it's 0 or not. Okay, it's 0 is fine. 0 for numerator is fine. So 4x plus 1 now can be equals to 0. Okay, it can be 0 now. But what can't be 0 is 2x minus 1 can't be 0. So that can't be 0. So what we will have is x greater or equals to negative a quarter and x is not half. Okay, again I will use number line. Negative a quarter is here. Well, I will say a half is here. Just write, I don't need to make it into scale, just make it at the right place. Negative that, well, it's all the way to there. And I don't want a half. Cut it there. Okay, so stop it there. And then just reconnect after a half. So I don't want a half. It's an open circle on a half. So the value I can take 2 ways to write it again. Well, my preferred way will be from negative a quarter to infinity, exclude a curly bracket, a half. It must be set difference. Okay, set difference. Set difference, another set. So half is not a set. I need to put in a curly bracket to make it like a set. Okay, make it into a set. Exclude one value. Okay, this is an interval from negative a quarter to infinity. All the values fine except a half. Another way to write this will be square bracket a quarter to a half, round bracket, union a half to infinity. I just exclude a half from both sets. I just cut it there. Okay, cut it there, and then start again. Okay, any questions to those 4? Okay, if no, I will stop here today, okay? Yes?